So we've been talking about complex numbers, square roots, imaginary numbers, and I've said before that you can't take the square root of a negative number. We know that the square root of 16 is 4, right? But we can actually do the square root of negative 16. We'll come back to that. What does the square root of negative 1 mean? What it means is I. I for imaginary number. Okay? So if that's the case, if I have the square root of negative 1 and then I square it, well, that becomes I squared. So what I'm trying to say here is that I squared equals negative 1. Okay? Now to simplify each square root, so what I mean by that is I can remember yesterday how we could take like square root of 20 and make it square root of 4 and square root of 5 and get 2 square roots of 5. Well, similarly with this, we can separate it into 16 and negative 1. I know the square root of 16 is 4. The square root of negative 1, I just got done telling you it's I. It's like it replaces that. So I get 4I. I'm not worried about plus or minuses right now. So for instance, on number 1, I get the square root of 9 times the square root of negative 1, which is 3I. Okay. Try number 2 and number 3 in a minute. Press pause. Alright, this becomes the square root of 36 times square root of negative 1. I get 6I. This becomes the square root of negative 4 because you always simplify fractions first, which is the square root of 4 times the square root of negative 1, which is 2I. And it is that simple. Now, of course, we're going to break some up like 20 that are going to get a little bit harder. Okay, but that's essentially what we're doing. Now, there is a difference between an imaginary number and a complex number. An imaginary number, we talked about this in the notes yesterday. Imaginary is just a number with I. Okay. Complex numbers, on the other hand, okay, I know it's bold, but I'm underlining it here, are numbers in the form of A plus BI. In other words, a number plus another number attached to I. Like we're going to end up here, like you can see down on 7, 8, and 9. Okay. So where A and B are real numbers, including 0. Now here's the thing. A plus BI is standard form. It's written in that form. We have not talked about that yet. I have not forced you to do that. But for a complex number, in other words, don't write it as BI plus A. Okay, we want it in this form. Now the additive inverse is essentially, if I have A plus BI, well then the additive inverse is like taking negative 1 times that, no matter what it is, and getting the exact opposite of each term. Okay, so with that being said, we're going to talk about that down here. That's pretty easy stuff. What we're going to do here is write this as a complex number. And again, a complex number is A plus BI. So here, I don't have to do anything with this 6. I'm just going to rewrite it. This becomes square root of 4 times square root of negative 1. That's how I get 2. That's how I get I. And I cannot combine those. So it'd be like 6 plus 2x. It doesn't give me 8x. It's 6 plus 2x. So that's my final answer. Similarly, this is square root of 9, square root of 2, and square root of negative 1. Well, 7 plus, I can do this one. That's 3. I can do this one. That's I. The one that I can't just comes along for the ride. We talked about that yesterday. The only difference here is the I because of the negative. Similarly here, 9 plus. Again, this breaks down. A lot of you are going to pick 4 and 8. And that's true, except for 8 can get down broken further into that. So I would get this, square root of 4 is 2, square root of 4 is 2, square root of 2 is square root of 2, and I get 4 square roots of 2. But instead, if I make this 16 and 2 and negative 1, so try and find the biggest number that goes into them. If you find 4, there's nothing wrong with it. I just don't like this because people leave it as 2 square roots of 8 instead of breaking it down further to get us what we see, which is 4I square roots of 2. Now some of you are going to write it like this, 4 square roots of 2I. And that's not wrong, but you better make sure I don't have to guess. If this square root is only over the 2, then I can see that. But right now, it kind of looks like, is it over the I? Is it not over the I? Don't make me guess. If we have to guess, it's wrong. I would just prefer you to write it in between because it's just easier to see it that way. Okay? And so I know that you know what I'm talking about here. Now, the additive inverse here of each complex number is literally, again, just the opposite. So as you guessed it for number 7, it's negative 4 plus 3i. Try 8 and 9 real quick. That simple. Just take the opposite of every term. Okay. Now again, remember, square root of negative 1 is what? I. So I squared. Well, I said that up top. Square that would be, well, let's take a look. What happens when I do that? I get square root of negative 1 squared. Well, what happens when I square things? This and this cancel out, and I get negative 1. If you'd like to see it this way, square root of negative 1 times square root of negative 1, well, it doesn't really work out as well, so let's just pretend I didn't do that. The squares will cancel each other out. So what I'm trying to get at is, down here in this problem, it's like combining, make this a x. If I had 5 plus 7x plus negative 2 plus 6x, you would just combine your like terms, and you combine your like terms. And it's the same thing here. This is really 5 plus 7i, because it's a plus problem, really nothing's changing. And I'm just combining my like terms. 3 plus 13i. Now again, with that being said, it is in standard form. That's the way I want you to write. I don't want you to write 13i. Oh, you can't see any of that. I'm sorry. Let me go through that one more time. 5 plus negative 2, 7i plus 6i gives me 3 and 13i. And I don't want to write 13i plus 3. That's not in standard form. Okay. Now over here, this is like a negative 1 that needs to get distributed first. 7 minus 3 minus 2i, or if you like, plus a negative plus a negative. I can see the two terms I need to do, and the term that I don't just kind of comes along for the ride in standard form. This is not a FOIL problem. FOIL problems look like this, where there is no space in between the parentheses. That's not what this is. Okay? We're going to see that actually on the next page. Okay. If I look at number 12, okay, what do I got to do on number 12? Well, I'm literally just multiplying this term times this term. So 5 times negative 4 is negative 20. I times I, let's write that down, I times I is I squared. Well, what is I squared? We said on the previous page, if you don't remember, and that's why I'm writing it at the top of this page, that I squared is negative 1. So what I can do is replace it. Negative 20 times negative 1 is 20, and that is the solution to that problem. Similarly, in this problem, this is a FOIL problem because, again, there is no space here. So I'm going to FOIL it first. Outside, sorry, that's a 12, not an 18. Inside, and last, which is plus 18i squared. Again, this is negative 1, so what I really have here is negative 6 plus 12i minus 9i. Well, 18 times negative 1 is negative 18. So plus a negative, or just negative. Now just combine like terms. Negative 24 plus 3i, and that is my solution. Try number 14 and try number 15, and then so press pause and then come back and check on me. So I did the FOIL process. I see I squared, which is negative 1. So really what I have here is minus a negative 1, which is how it becomes a plus. Combine my like terms. Combine my like terms. 7 minus 1i or 7 minus I, either way. Okay. For this one again, FOIL it out. 2i squared minus 6i plus 1i minus 3. This I know is negative 1 times 2 is negative 2 minus 6i plus 1i minus 3. Combine my like terms, combine my like terms, and there's my answer. Okay. Down here, we're going to solve these, and you're just going to see more ways that this I is going to show up. To solve this, treat it like an x. What would you do first? Minus 100. Those cancel. 4x squared equals negative 100. And then, of course, I would divide by 4. X squared equals negative 25. And the last step to solve, what's the opposite of squaring something? Is to square root it. Now again, this breaks into square root of 25 and square root of negative 1. So x equals, well, 5i. Except, anytime you take a square root, remember, it's plus or minus, which again should make sense. If that's a 2, it better have 2 solutions. All of them are going to have 2 solutions. Let's look at the next one. What would you do first? add 72. Negative 2x squared equals 72. Divide by negative 2. X squared equals negative 36. And of course, when we square root it, 36 and negative 1, I get x equals plus or minus, because I square rooted, 6i. Okay. Now you try 17 and 18 and come back and check it in just a minute. So if you haven't seen it already, the bottom two are a lot crazier at the end, but not really. This is the same steps, and I did it purposely by doing the same step first on both these and then the same step second. We're getting rid of the number that's being added or subtracted. We're doing the opposite of the number being multiplied. And I get down to my x squared. And again, we know the last step is to square root, and when we square root, we're going to get plus or minus, so maybe I can write that for both of these first. For this, it breaks down into square root of 5 and square root of negative 1. So this is literally I square roots of 5. That's it. For this one, though, we got to break that down further. And again, if you start going through your list and you're like 4, 9, 16, 4 goes into it 50 times, but then 50 breaks into 25 and 2. So look for the highest number. And the highest number that is a perfect square, that means that we can take a square root of it, that goes into 200, is of course 100. We know the square root of 100. And the square root of 2. And I get the square root of negative 1 out here. The one I can do, we'll write out here first. The one I can do, we can write out here next. The one I can't just comes along for the ride. And that's it. That's the notes. Fairly quickly through it. Hopefully you tried some of this on your own. Your homework is the next page, 1 through 18, and you're going to find that this is very similar to what you're going to see on the quiz tomorrow. You are going to get a practice quiz tomorrow, which will be another version of pretty much this. And then you will get a quiz right after that. Please make sure you're doing at least 1 or 2 from each section. We want you to do the whole thing, but at least so you know what's coming on the quiz tomorrow. Have a good day.